Canadian Electrical Code, or CEC. Part 1 is Canada's equivalent to the United States National Electrical Safety Code, or NESC. It's the primary standard for electrical installations throughout Canada. The Canadian Standards Association, or CSA, publishes and maintains the CEC. It serves as the guiding document for electrical inspectors, contractors, and engineers ensuring safe and compliant electrical work. While the CEC shares a foundation with the NESC reflecting common electrical engineering principles, it's crucial to understand that it's not simply a direct copy. The CEC is tailored to the specific needs and regulatory environment of Canada. There are key differences between the two codes. The CEC addresses situations and technologies relevant to Canada. For example, the CEC includes specific requirements for electrical installations in hazardous locations. These locations might include oil and gas facilities where explosive atmospheres are a concern. It also has requirements for the installation of electric vehicle charging stations. The code adapts to evolving technology, so the CEC is updated regularly, typically every 3 years. These updates incorporate changes in technology, address new safety concerns, and reflect industry best practices. The current edition of the CEC is CSA 22.1-21. It is essential to use the most up-to-date version of the code. When working on electrical projects in Canada, always consult the latest version of the CEC. It is important to familiarize yourself with its specific requirements. Some key areas covered in the CEC include general requirements, wiring methods, protection and control, grounding and bonding, equipment installation, special occupancies, and hazardous locations. Firstly, the general requirements section outlines the fundamental principles governing electrical installations. This includes things like conductor sizing, overcurrent protection, and working clearances. Secondly, wiring methods specify acceptable ways to install electrical conductors. This covers various types of cables, conduits, and other wiring systems. Thirdly, the protection and control section focuses on safeguarding electrical systems and equipment from overloads, short circuits, and other faults. This includes requirements for circuit breakers, fuses, and ground fault circuit interrupters. Fourthly, grounding and bonding are crucial for safety, providing a low impedance path for fault currents to return to the source. This section details how to properly ground and bond electrical systems and equipment. Fifthly, the equipment installation covers the proper installation of various electrical equipment. This section addresses things like transformers, motors, and lighting fixtures. Sixthly, special occupancies address electrical installations in unique environments. This could include hospitals, theaters, and agricultural buildings. Seventhly, hazardous locations provide guidance for electrical installations in areas where flammable gases, vapors, or dust are present. Always consult with qualified electrical professionals who are familiar with the CEC when planning and executing electrical work in Canada. They can help ensure compliance and safety. Navigating the Canadian Electrical Code requires a methodical approach. It's a comprehensive document, so understanding its structure and key sections is crucial for efficient use. Firstly, obtain the correct version. Make sure you have the latest edition of the CEC, which is CSA 22.1. These codes are updated regularly, and using an outdated version can lead to non-compliance. Secondly, familiarize yourself with the code structure. The CEC is divided into sections, each addressing specific aspects of electrical installations. These sections are further broken down into rules. Thirdly, use the table of contents and index. These tools are essential for quickly locating the specific rules relevant to your project. The table of contents provides a high-level overview of the code's organization, while the index allows you to search for specific terms and topics. Fourthly, understand the definitions. The CEC includes a section dedicated to definitions of terms used throughout the code. It's important to understand these definitions to correctly interpret the rules. Fifthly, pay attention to appendices. The CEC includes appendices that provide additional information, examples, and guidance on certain topics. These appendices are not mandatory requirements, but they can be helpful for understanding and applying the code. Sixthly, read the rules carefully. When you find a rule that you think is relevant, read it carefully and make sure you understand its requirements. Pay attention to any exceptions or qualifications. Seventhly, consult with experts. If you're unsure about how to apply a particular rule, consult with a qualified electrical inspector or engineer. They can provide guidance and help you ensure compliance. Some specific examples of requirements covered by the CEC include conductor ampacity. The CEC specifies the allowable ampacity or current carrying capacity of different types of conductors. This is crucial for ensuring that conductors don't overheat and cause a fire. Another example is overcurrent protection. The CEC requires that electrical circuits be protected by overcurrent devices, such as circuit breakers or fuses. These devices are designed to interrupt the circuit if the current exceeds a safe level. Also, grounding electrode system. The CEC specifies the requirements for grounding electrode systems, which are used to connect electrical systems to the earth. This helps to protect against electric shock and equipment damage. Another example is wiring in hazardous locations. The CEC has specific requirements for wiring in hazardous locations, such as areas where flammable gases or vapors are present. These requirements are designed to prevent explosions and fires. One thing to note is that the CEC uses metric units. The CEC uses metric units for all measurements. You may need to convert from imperial units if you're more familiar with those. Another important consideration is provincial and territorial variations. Electrical regulations in Canada are primarily governed at the provincial and territorial level. While the CEC serves as a base standard, each province and territory may adopt it with amendments or have its own unique regulations. Therefore, it's crucial to consult the specific electrical code and regulations applicable in your jurisdiction. To find this information, check the website of the regulatory authority responsible for electrical safety in the province or territory where you're working. This information can also be obtained by contacting local electrical inspectors or trade organizations. Some provinces and territories publish their own versions of the electrical code, incorporating the CEC with their own amendments. These versions may have different numbering systems or additional requirements. It is also important to stay updated on any bulletins, interpretations, or directives issued by the regulatory authority. These documents provide clarifications and guidance on specific code requirements. Non-compliance with the electrical code and regulations can result in penalties, fines, and delays in project completion. It can also create safety hazards and increase the risk of electrical accidents. For example, let's say you're installing a new electrical panel in a residential building in Ontario. Ontario adopts the CEC with some amendment. You'll need to consult both the CEC and the Ontario Electrical Safety Code to ensure compliance. The Ontario Electrical Safety Code may have additional requirements for things like bonding and grounding. Also, you're wiring a commercial building in Alberta. Alberta adopts the CEC with some amendments. You'll need to consult both the CEC and the Alberta Electrical Utility Code to ensure compliance. The Alberta Electrical Utility Code may have additional requirements for things like wiring methods and overcurrent protection. Suppose you are installing electrical equipment in a hazardous location in Quebec. Quebec adopts the CEC with some amendments. You'll need to consult both the CEC and the Quebec Construction Code, Chapter 5 Electricity, to ensure compliance. The Quebec Construction Code may have additional requirements for things like explosion-proof enclosures and intrinsically safe circuits. Let's say you're installing a solar panel system on a roof in British Columbia. British Columbia adopts the CEC with some amendments. You'll need to consult both the CEC and the British Columbia Electrical Code to ensure compliance. The British Columbia Electrical Code may have additional requirements for things like disconnect switches and labeling. Also, you're running electrical wiring in a hospital in Manitoba. Manitoba adopts the CEC with some amendments. You'll need to consult both the CEC and the Manitoba Electrical Code to ensure compliance. The Manitoba Electrical Code may have additional requirements for things like emergency power systems and grounding. Keep in mind that electrical codes and regulations are constantly evolving. It's important to stay informed about the latest changes and updates. Attending industry training courses, subscribing to relevant publications, and participating in professional organizations can help you stay current. Another thing to remember is that the CEC is not a substitute for proper electrical training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills. Attempting to perform electrical work without proper training can be dangerous and can result in serious injury or death. For example, the CEC specifies requirements for conductor sizing based on the ampacity of the circuit. Improperly sized conductors can overheat and cause a fire. Let's say you are installing a 20 amp circuit. According to the CEC, you would typically need to use number 12 American wire gauge copper conductors. Another example is that the CEC requires that electrical circuits be protected by overcurrent devices. Using the wrong size overcurrent device can result in equipment damage or a fire. You have a motor rated for 15 amps. According to the CEC, you would typically need to use a 20 amp circuit breaker to protect the motor. Also, the CEC specifies requirements for grounding and bonding electrical systems. Improper grounding and bonding can result in electric shock. You are installing a metal water pipe near an electrical panel. According to the CEC, you would need to bond the water pipe to the grounding system to prevent electric shock. One other example is that the CEC has specific requirements for wiring in hazardous locations. Using non-approved equipment in a hazardous location can result in an explosion. You are installing lighting fixtures in a paint booth. According to the CEC, you would need to use explosion-proof lighting fixtures. The Canadian Electrical Code is a comprehensive document that covers a wide range of electrical installations. It is important to understand the code structure in key sections. You should consult with experts when you are unsure about how to apply a particular rule. Remember that electrical codes and regulations are constantly evolving. It is important to stay informed about the latest changes and updates. The CEC is not a substitute for proper electrical training and experience. Electrical work should only be performed by qualified individuals who have the necessary knowledge and skills. The CEC is crucial for ensuring electrical safety in Canada. Understanding and adhering to its requirements is essential for all electrical professionals.